Here we have a problem on logarithm. Okay, let's read the question. If log x to the base 2 plus log x to the base 4 plus log x to the base 16 is equal to 21 divided by 4, find the value of x. So in the given equation, log x to the base 2 plus log x to the base 4 log x to the base 16 equal to 21 by 4, we have to solve for x, that is we have to find the value of x. Here we have addition of three logarithms. So the first fundamental of logarithm is given for addition of two or more logarithms, but the first fundamental of logarithm can be used if all the logarithms have the same base. But here the base for all the three logarithms is different. So here the base of the first logarithm is 2, the second one is 4, the third one is 16. So we will not be able to use the first fundamental law. Only if the base is same for all the logarithms which are in addition, we will be able to use the first fundamental law. So here we cannot use. So to solve for x in this one, what I am going to do is, I assume there is 1 multiplied in front of each logarithm. So now what I am going to do is, I am going to switch this log x to the base 2 to the denominator. Whenever I switch a logarithm from numerator to denominator or denominator to numerator, have to interchange the argument and base. So I get in the first fraction I get 1 divided by log 2 to the base x. So when this logarithm goes to denominator, so the argument x should be taken as base and the base 2 should be taken as argument, that is we have to interchange these two. So the same thing we have to do here in the second term. Then we will get 1 divided by log 4 to the base x, and here 1 divided by log 16 to the base x, so is equal to 21 divided by 4. Okay, here for all these three logarithms we got the same base, but all of them are in denominator. Okay, so let's simplify this one. 1 divided by log 2 to the base x, the second fraction, so this 4 can be written as 2 square, so log 2 square to the base x plus 1 divided by log 2 to the power 4 to the base x is equal to 21 divided by 4. 1 divided by log 2 to the base x plus 1 divided by, here we can use the third fundamental law, that is we can get this exponent 2 in front of the logarithm. So we get 2 log 2 to the base x. So the same, we can get the exponent 4 in front of logarithm. 1 divided by 4 log 2 to the base x is equal to 21 divided by 4. Okay, here I need to add the three fractions. So to add the three fractions, I need to have the same denominator for all the three fractions. So in all the three fractions, I find log 2 to the base x in common. But in the third fraction, we have 4 multiplied by the logarithm. In the second one, we have 2 multiplied by the logarithm. And the first one, we have there is 1. Actually, no number is there, but we have to assume there is 1. Okay, so to get the same denominator for all the three fractions, what I am going to do is, I am going to multiply the second fraction, numerator and denominator of the second fraction by 2, and numerator and denominator of the first fraction by 4. So I get 4 divided by 4 divided by 4 log 2 to the base x plus 2 divided by 4 log 2 to the base x plus 1 divided by 4 log 2 to the base x is equal to 21 divided by 4. Okay, now we got the same denominator for all the three fractions. So now what we can do is, we can take the common denominator and add the numerators. That is 4 plus 2 plus 1 divided by, the common denominator is 4 log 2 to the base x is equal to 21 divided by 4. Okay, so when I add 4, 2 and 1, I get 7. 7 divided by 4 log 2 to the base x is equal to 21 divided by 4. Okay, now what I am going to do is, I am going to switch this log 2 to the base x to numerator. So when it is taken to the numerator, we have to interchange the base and argument. Then we get log x to the base 2 divided by 4 is equal to 21 divided by 4. Okay, now if I move this 7 divided by 4 to the right side of the equation, it will become 4 divided by 7. So we get log x to the base 2 is equal to 21 divided by 4 times 4 divided by 7. If I simplify this one, 4 can be cancelled out. 1 times 7 is 7. 7 goes into 21 3 times. 1 second. Okay, so we get log x to the base 2 is equal to 3. Okay, now I need x. So what I am going to do is I am going to move this log to the base 2 on the right side of the equation. So whenever I move logarithm with the base from one side of the equation to the other side, we have to ignore the logarithm. We have to consider only the base on the other side. The value which already exists on the other side will become the exponent of this base. So we get x is equal to 2 cube is equal to 8. So finally the value of x is 8.